Deep beneath the Earth's surface, a dramatic event is unfolding. The ground beneath our feet, which we often take for granted, is far from stable. It's a dynamic, ever-changing environment, constantly in motion due to the immense forces at play within the Earth's crust. The Indian Tectonic Plate, one of the planet's largest, is splitting apart. This colossal slab of the Earth's crust is undergoing a transformation that could reshape the geography of our world. The tectonic plates are like giant puzzle pieces that make up the Earth's surface, and the Indian Plate is one of the most significant pieces in this global puzzle. This isn't happening in some remote, unpopulated corner of the world. It's taking place in regions teeming with life, where millions of people live, work, and go about their daily lives. The implications of such a tectonic shift are profound, affecting not just the landscape, but also the lives of those who inhabit these areas. It's occurring right under the Himalayas, the tallest mountain range on Earth. These majestic peaks, which have stood as silent sentinels for millions of years, are now at the epicenter of this geological drama. The Himalayas themselves were born from the collision of tectonic plates, and now they are witnessing another chapter in this ongoing saga. Talk about a shaky situation. The ground beneath the Himalayas is not just moving, it's trembling with seismic activity. Earthquakes are a stark reminder of the immense power locked within the Earth's crust, and the potential for future quakes in this region is a cause for concern. This groundbreaking discovery has sent shockwaves through the scientific community, and it all starts with a tectonic plate on the move. Geologists and seismologists are now racing to understand the full implications of this tectonic shift. Their research could provide crucial insights into the future of our planet's geology and help us prepare for the challenges ahead. The story begins millions of years ago. The Earth was a very different place back then, with continents arranged in configurations that are almost unrecognizable today. The forces that drive tectonic movement have been at work for eons, shaping the world we know. Back then, the Indian subcontinent wasn't even part of Asia. It was a separate landmass, isolated from the rest of the world's continents. This isolation would not last forever, as the forces of plate tectonics had other plans. It was an island, adrift in the vast ocean. Imagine a lonely landmass surrounded by endless water slowly making its way across the globe. This journey would take millions of years, but it was a journey with a destination that would change the world. But it wasn't content to stay put. The Indian Plate was driven by powerful forces deep within the Earth, forces that are still at work today. These forces are responsible for the movement of tectonic plates, the creation of mountains, and the occurrence of earthquakes. Driven by forces deep within the Earth, the Indian Plate embarked on a journey, slowly but surely drifting north. This movement was not random. It was part of a larger pattern of tectonic activity that has been shaping our planet for billions of years. It was a journey that would have a profound impact on the geography of our planet. The collision of tectonic plates has created some of the most dramatic landscapes on Earth, from towering mountain ranges to deep ocean trenches. This movement wasn't just a leisurely drift, it was a slow-motion collision course, a geological dance that would culminate in a dramatic encounter. The forces at play were immense, capable of reshaping entire continents. It was a slow-motion collision course. The Indian Plate was on a path that would bring it into direct contact with the Eurasian Plate, setting the stage for one of the most significant geological events in Earth's history. The Indian Plate was headed straight for the Eurasian Plate, one of the giants of the tectonic world. This collision would not be a gentle meeting but a powerful clash of titanic forces. When these two massive plates met, the result was nothing short of spectacular. The collision gave rise to the Himalayas, the tallest mountain range on Earth, and continues to shape the region to this day. Think of it as a geological slow-motion car crash, but on an epic scale. The forces involved are almost beyond comprehension, and the results are etched into the very fabric of our planet's surface. This ongoing tectonic activity serves as a reminder of the dynamic nature of our Earth and the powerful forces that continue to shape it. The collision of the Indian and Eurasian plates is one of the most significant geological events in Earth's history, shaping the planet as we know it. It's the force responsible for the creation of the Himalayas, those towering peaks that have captivated explorers and adventurers for centuries. As the two plates collided, their edges crumpled and folded, pushing up the land into the sky, forming majestic mountains. Imagine two enormous slabs of rock, each thousands of miles across, slowly pushing against each other. The pressure is unimaginable. Over millions of years, this relentless force created the highest mountains on Earth, a testament to the immense power of plate tectonics. But the story doesn't end there. The Indian Plate's northward journey didn't stop after the initial collision. It continued to push and grind against the Eurasian Plate, a process that continues to this very day. It's this ongoing pressure that has led to the recent discovery that's shaking up the world of geology. Scientists didn't just stumble upon the fact that the Indian Plate is splitting. This discovery was the result of years of painstaking research and collaboration among geologists, seismologists, and other experts from around the world. It took years of meticulous research, using cutting-edge technology to peer deep beneath the Earth's surface. These technologies include advanced geological survey equipment and 3D seismic imaging, which allow scientists to visualize the hidden structures of our planet with unprecedented clarity. Think of it like a giant planetary-scale ultrasound. Just as doctors use ultrasound to see inside the human body, geologists use seismic waves to see inside the Earth. By studying the way seismic waves travel through the Earth, scientists can create images of the structures hidden beneath our feet. These waves move at different speeds depending on the materials they pass through, revealing a detailed picture of the Earth's interior. One of the key pieces of evidence came from studying earthquakes in the region. Earthquakes provide a natural way to probe the Earth's interior, as the shock waves they generate travel through the planet and can be detected by seismographs. Earthquakes are essentially shock waves caused by the sudden release of energy within the Earth's crust. This energy release occurs when stress that has built up over time is suddenly released, causing the ground to shake. By analyzing the patterns of these shock waves, scientists can pinpoint the location and depth of the fault lines where the Earth is breaking apart. This information is crucial for understanding the dynamics of tectonic plates and predicting future seismic activity. In the case of the Indian Plate, scientists noticed something peculiar. The seismic data revealed unusual patterns of earthquake activity that didn't match the expected behavior of a single, unified plate. The pattern of earthquakes wasn't what they expected to see from a single unified plate. Instead of a uniform distribution of seismic activity, the data showed distinct clusters of earthquakes, suggesting that the plate was experiencing different forces in different areas. Instead, the data suggested that the plate was being pulled in two different directions, like a piece of taffy being stretched. This stretching indicates that the Indian Plate is in the process of splitting into two smaller plates, a process that will continue to shape the region's geology for millions of years to come. This discovery has profound implications for our understanding of plate tectonics and the geological history of the Indian subcontinent. By comparing historical geological maps with modern data, scientists can trace the evolution of the Indian Plate and predict how it will continue to change in the future. The research findings have been presented at numerous scientific conferences, sparking discussions and further investigations into the mechanisms driving the plate's movement. Animated infographics and detailed geological samples help to illustrate the complex processes at work. Satellite imagery and remote sensing technology also play a crucial role in monitoring the Indian Plate's activity. These tools provide a global perspective, allowing scientists to observe the interactions between different tectonic plates and their impact on the Earth's surface. Field studies and rock sample analyses complement the high-tech methods, providing tangible evidence of the forces at work. By examining rock formations and collecting data in the field, scientists can piece together a geological timeline that reveals the history of the Indian Plate's movements. This research is a testament to the power of collaboration and the importance of a multidisciplinary approach. Geologists, seismologists, and other experts from around the world work together, sharing data and insights to build a comprehensive understanding of the Indian Plate's behavior. As we continue to refine our techniques and gather more data, our understanding of the Earth's interior and the forces that shape it will only grow. This knowledge not only helps us predict future geological events but also deepens our appreciation for the dynamic planet we call home. So, why is the Indian Plate splitting apart? This question has intrigued scientists and geologists for decades, leading to extensive research and numerous theories. The answer lies in the immense forces at play deep beneath the Earth's surface. These forces are not just random occurrences but are the result of complex interactions between various geological processes. The ongoing collision with the Eurasian Plate has created a zone of intense pressure and stress beneath the Tibetan Plateau. This collision is a slow but relentless process, occurring over millions of years. It's like trying to squeeze a watermelon into a shoebox. Something has to give. The forces involved are so immense that they can reshape entire landscapes and create new geological features. The Tibetan Plateau itself is a testament to the incredible power of these tectonic forces. Rising over 4,500 meters above sea level, it is a region of superlatives. It's the largest and highest plateau on Earth, often referred to as the roof of the world. Its sheer size and altitude make it a unique and fascinating subject of study. A vast expanse of high-altitude plains and towering mountains. These features are not just scenic wonders but are also key indicators of the geological processes at work. But this geological marvel comes at a price. The immense pressure and stress have created a fragile and unstable environment. The constant pressure from the Indian Plate has created a network of faults and cracks in the Earth's crust, making the region prone to earthquakes and other geological hazards, like cracks in a windshield. These faults and cracks are not just surface features, but extend deep into the Earth's crust, affecting its stability. Think of it like this. Imagine the Earth's crust as a block of clay. Imagine pushing on a block of clay from one side. The clay will initially resist the pressure, but as the force increases, it will start to deform. At first, the clay will deform and bulge. This is similar to how the Earth's crust responds to tectonic forces, by bending and warping. But if you keep pushing, eventually the clay will start to crack and break apart. This is exactly what happens when the stress exceeds the material's ability to deform. That's essentially what's happening to the Indian Plate beneath the Tibetan Plateau. The relentless pressure is causing it to fracture and split. The constant pressure has pushed the plate to its breaking point, leading to the formation of new faults and the reactivation of old ones, causing it to split along these pre-existing weaknesses in the Earth's crust. This process is ongoing and continues to shape the landscape, creating new challenges and opportunities for scientists to study.